Hi, welcome to my channel. This is question 2 trigonometry A level. Now here we are given parametric equations and we need to eliminate the theta. We form Cartesian equations. So we have the first one as x equal to a cos theta and y equal to b sin theta. So now you should always remember the trigonometric identities we have derived, the Pythagoras trigonometric identities. I want you to remember that there is 1 of sine squared theta plus cos squared theta equal to a 1. So when we see an equation, when there is, it can be one parametric equation can be expressed in terms of cos. Cos can be made a subject and even sine made a subject. So squaring and add, you can easily eliminate that parameter theta. So like here, you see a cos and you see a sine. You can easily make cos the subject. So you will see cos theta equal to x over a. So go ahead and get cos squared theta. That is x squared over a squared. The same applies here. You shall see that sine theta is y over b. So sine squared theta is y squared over b squared. That is equation 2. So when you add 1 and 2, you get sine squared plus cos squared, or cos squared plus sine squared. We shall be having x squared over a squared plus y squared over b squared equal to sine squared plus cos squared. But now this is 1, hence the equation without theta is x squared over a squared plus y squared over b squared equal to 1. So that is 1. Let us see 2. Now let us see Roman numeral 2. Now Roman numeral 2, we have a cot and a cosec. Don't forget an identity of 1 plus cot squared theta equal to cosec squared theta. So again here you see that if we make cot the subject and cosec the subject, we square, we can just replace them here in this identity. So let us see, when you have x equal to a cot theta, you can make cot theta the subject, which is x over a, and when you square both sides, you get cot squared theta equal to x squared over a squared. So we have got that. And this is 1. We shall use this. Now this is 2. Then we can make cosec the subject. So cosec theta will be y over b. So cosec squared will be y squared over b squared. That is. Now we are going to put 2 and 3 in 1. This trigonometric identity, we already derived it. So when you substitute, we shall get 1 plus cot squared. Cot squared theta is x squared over a squared equaling to cosec squared. Our cosec squared is y squared over b squared. Can you correct the algebra and put them on one side? So this can be y squared over b squared minus x squared over a squared equal to 1. Well, let us see Roman numeral 3 now. Now Roman numeral 3 we have a tan and cos. Now whenever you have a tan and a cos, and you can make them the subject, the identity you should look at is the one of 1 plus tan square theta equal to sec squared theta. You may observe that here we don't have sec, we have cos, but don't forget that 1 over cos will be sec, so you can again get your sec squared. So let us look for tan. Tan theta is going to be x over a, so tan squared will be x squared over a squared. That is 1. Then this is 1, this is 2. Now let us see cos theta is going to be y over b, implying that 1 over cos is equal to b over y, but this is sec, so sec theta will be b over y, and sec squared will be b squared over y. So if this is equation 3, I'm going to add to get to 2 and 3, and I put these 2 into 1. So putting 2 and 3 in 1, we shall get 1 plus tan squared is x squared over a squared equaling to b squared over y squared. This is the required equation. Again, you can put the algebra on the other side, so we can get b squared over y squared, then minus, if you take this on the other side, x squared over a squared equal to 1. Yes, now let us see Roman numeral 4. Now Roman numeral 4, again you can see how sine and cos. You can make sine the subject and cos the subject. So for Roman numeral 4, we shall use an identity of sine squared theta plus cos squared theta equal to 1. So here what we do is to make sine the subject. So sine theta is going to be 1 minus x. So sine squared theta will be 1 minus x squared. So this is equation 2, if I call this 1. Then the cos theta will be y minus 1, and cos squared will be y minus 1 squared. So if I put 2 and 3 in 1, I get rid of the theta, that parameter. So 2 and 3 in 1, we shall be getting 1 minus x squared plus y minus 1 squared equal to sine squared plus cos squared, sine squared plus cos squared. This is squared. So this gives us a 1 as our required equation. Roman numeral 5. Now here we have a sine and a tan. So whenever you have a sine and a tan and you can make them the subject, the identity to use is 1 plus cot squared theta equal to cosec squared theta. We don't have cot here and we don't have cosec here. However, if you can get a tan is 1 over cot. Similarly, sine is 1 over cosec. So it is very easy now. When you get a sine and if you just make tan the subject, or you create the expression of tan, then you find its reciprocal, you will get a cot, and cot squared can be now placed here in the identity. So let us see, how can we create a tan from here? Now these are two equations. We have sine plus tan, then we have tan minus sine. Now the difference in sine here helps us to eliminate one trigonometric ratio. For example, I have x equal to sine theta plus tan theta. Then I have y equal to tan theta minus sine theta. If I add these two, what happens? When I add them, the sine disappear, I mean with 2 tan. So we shall get x plus y equal to 2 tan theta. So which can be written as tan theta, then I divide by 2. So I call this one my equation. So if I want to get, before I label it, because I'm interested in cot, to use this identity. So the cot theta will be 2 over x plus y, and the cot squared is going to be this squared, which is going to be 4 over x plus y squared. So I call that one 2. Now, what if I subtract these equations? I have sine theta plus tan theta equal to x. Also, sine theta plus tan theta is equal to x. Then we also have here tan theta minus sine theta equal to y. So if I subtract these equations, now I'll be getting rid of the tan. So I get sine minus minus, which is 2 sine. So this is going to be 2 sine theta equal to x minus y, meaning that my sine theta is x minus y over 2, and the reciprocal, which is the cosec theta, will be 2 over x minus y. So let me create some space here. So the cosec squared theta will be 4 over x minus y. That is equation 3. So I can now put 2 and 3 in 1. So I get 1 plus cot squared is 4 over x plus y squared. This was a plus y, then equal to cosec squared, and the cosec squared is here, this is squared, is 4 over x minus y squared. Finally, we are going to do Roman numeral 6. It is not straightforward, it's a little bit tricky, but we shall see how we handle it. So now we have sine, cosine, cos, and when you have sine and cos, the identity used is sine theta squared plus cos squared theta equal to 1. But now when you look at these two equations, it's not that if we add them, we eliminate one trigonometric ratio and we remain with 1. No way. So what we can do now is to use substitution. We can make cos the subject here and write it in terms of sine. Then we come and substitute for cos here so that we remain with only sine. Then we make sine the subject. So this is what I mean. From this one here, x cos theta is going to be a minus y sine theta, meaning that my cos theta will be a minus y sine theta divided by x. Then we come and we substitute the cos here. From the second equation, we have x sine theta minus y. Now where there is a cos, we are going to put this so that we remain with an equation which is having only sine. So where there is a cos, I will say a minus y sine theta divided by x equal to b. So now I can easily get my sine theta. So this is going to be, let me first remove this denominator. I'm going to multiply with x throughout. So this will be x squared sine theta minus, then the y will be multiplied in this bracket, that is going to be minus ay, then plus y squared sine theta equal to bx. Now when we factorize sine theta, here we shall remain with x squared, then here we shall remain with a plus y squared equal to bx. Then I take this the other side, that is going to be plus ay, meaning that my sine theta is going to be bx plus ay divided by x squared plus y squared. So this is equation 1, this is equation 2. Let me get sine squared. So sine squared theta will be equal to bx plus ay squared over x squared plus y squared also squared. So this is equation 2. Fine, now we have seen sine squared is equal to this. Now we are going to look for cos. We use the same idea. I'll just have to make sine the subject from one equation. Then I go to the second equation and substitute for it so that I remain with only cos in the expression. So from here, let me first make sine the subject and I substitute it in the second equation. So sine theta is going to be equal to a minus x cos theta divided by y. Then I come in this second equation where there is sine, I put this. Then I'll be having x, where there is sine, I'm going to remain substitute with a, then x cos theta divided by y, then minus y cos theta equal to b. As I did, I'm going to multiply with y throughout so that I get rid of this denominator. Then I'll multiply x in the bracket. I will get ax minus ax cos. No, this is going to be x squared cos. I beg your pardon. If I multiply with x, this is going to be x, but the other one will be minus x squared cos theta. Then the y I will multiply here will cancel with the denominator, but the other one will be minus y squared cos theta equal to by. So make cos the subject